Hey guys, welcome back. I hope everybody's warm, you have power, you don't have trees on your house or anything. I know this has been a very crazy week for a lot of people. Praying that you are safe. We're going to do class virtually this week. So just some housekeeping before we hop into chapter 8. If you have not finished the chapter 7 test, please do so before next Tuesday. I'm going to give you guys an extra week to turn that in. We're just going to cover one section this week, so we're not overloaded. I know you've got a lot on your plate with all that Tuesday and Thursday work moving to home. And part of your assignment for this week is review. So let me show you on your assignment sheet. All of this is posted on the portal, by the way. So the first part of your assignment is, like I said, finish your chapter 7 test. If you haven't, please make sure you show work for everything. If there's no work shown for a problem, you will not get credit. Okay, I put that at the top of the test. I'm going to do a lesson on 8.1. The video that it references right here, the 8.1 video, is what I'm doing now. I'll post that on the portal, obviously. Make sure you take notes, attempt the you-try problems, and then your assignment for that section is right here. And then the last part of your assignment for this week is some preview questions for section 8.2 that we will cover in class next week. And make sure to note, see this right here, we have a quiz over this section 8.1 next Tuesday. Let me know if any of that doesn't make sense or you're having trouble with the chapter 7 test. All right, so before we hop into section 8.1, this section is all about inverse variation. So we're going to talk about the difference between direct and inverse variation. Oh, my pen's going out. So direct variation, a relationship where x and y vary directly, can be written in the form y equals k times x, where k is just some number, some constant. So an example of this would be something like y equals 2x. So the reason we call this a direct variation, so as x increases or decreases, y is also going to do the same thing. So if I were to make a table of values for this, so x and y, so 1, 2, 3. So for x equals 1, y would be 2. For x equals 2, y would be 4, so on and so forth. So I can see that as my x's are increasing, so are my y's. Okay, they have a direct variation in their relationship. Likewise, if I had, even if this were to be a fraction, that same relationship would still be happening. Okay, as x increases, so does y, or vice versa. Okay, and these relationships can be in any form. We could have like pi times x. We just have to make sure that k is a constant number. Okay, now an inverse relationship is a little different. This is when instead of multiplication, we are going to see k divided by x, where k is still a constant, but x and y are going to have an inverse variation in their relationship, meaning as one increases, the other is going to decrease. Okay, so let's look at an example. So we're going to look at 2 divided by x. Okay, so let's again make a table. So for x and y, let's use those same numbers, 1, 2, and 3. So if I plug in 1 here for x, I'll have 2 divided by 1, which means y is 2. And then 2 divided by 2, as I move on to the next ordered pair, is going to be 1. And then 2 divided by 3 is a fraction. It's like 0.667. I don't have to keep going. I can see that as x is increasing, so as this is going up by 1, my outputs, my y values, are decreasing. Okay, so this makes this an inverse relationship. Okay, so another example of an inverse relationship would be 6 divided by x. Anything where you have a constant divided by your input, it could be negative 6 divided by x. We still have that relationship. So I would say if you wanted to write down a phrase to help you remember this, for a direct variation, you would say both increase or decrease And then inverse would be the opposite of that. So as one increases, the other decreases, or vice versa. Okay, so that's direct and inverse variation. So what we're going to do now is we're going to look at a table, and we're going to try to figure out if it is direct, inverse, or neither. Okay, this should not say direction, it should say direct. So sorry for that typo. Okay, so let's just look at the table, see if we can see any patterns that would help us determine if it's direct, inverse, or neither. Okay, so I can see these are in order. The x's are increasing, and then I can see from my y's, these are decreasing. So in my head, if x is increasing and then y is decreasing, that might show me an inverse relationship. So I'm asking myself, is this an inverse relationship? Okay, the only way I can tell that is if I can figure out an equation that works for all of these ordered pairs that is in the form y equals k divided by x. Okay, so let's see if we can figure that out. So I can see from these ordered pairs, how are 2 and 15 related? So 15 equals k divided by 2. Okay, is there any number that would work there that would have to be a 30? Okay, let's see if that same equation is going to work for 4 and 7.5. So I've got 7.5 equals 30 divided by, oh, sorry, that should be a 4. Sorry if you hear my kids screaming. 30 divided by 4, yes, that does work. Okay, I can see that it would work for this and for this. So yes, this is an inverse relationship. Okay, so yes, it is inverse. And now what we're going to do is we're going to write that function that models this relationship. So we just figured out k is 30, just through trial and error and guessing and checking with the points. So we can see for y, we're going to have 30 divided by x. So that would be my function for this inverse variation. Okay. All right, so if you feel like you understood that pretty well, maybe pause and see if you can figure this one out on your own. Again, I made a typo. This should say direct. Sorry about that. Okay, so we're going to do the same thing with this set of data. So we're going to look at the x's and the y's and see if we can determine direct, inverse, or neither. Okay, so again, I can see that as my x's are increasing, this time the y's are also increasing. Okay, so my only option here would either be direct or neither. So if it is direct, so we're going to write direct, question mark, we need to put it into this form, y equals kx. The data should, each of those data points should be in that format, okay? So let's check that first set of points. So we've got 8 equals k times 0.2. For the next set, we have 20 equals k times 0.5, 40 equals k times 1.0, and then the last set, 60 equals k times 1.5. Okay, so for all of these, if there's a k that works for each one of these equations, that means it has a direct variation. Okay, so each of these, if I were to go in and solve for k, I would get k equals 40. Okay. So now what we're going to do is we're going to write our equation, so our function rather. So y equals 40 times x, and this is a direct variation. As one increases, the other is also increasing. Okay? All right, so this example, so it says suppose x and y vary inversely. Okay, so that's telling me y equals k divided by x. So x is 4 when y is 12. So let's write a function that models this relationship. So what we need is k. All right, so using that format, y equals k divided by x, let's plug in our numbers. So y is 12. So I've got 12 equals, and then we don't know k, but we do know x is 4. Okay? right, so I'm asking myself some number divided by 4 equals 12, or I can just multiply both sides of that equation by 4, and that should tell me what k is. So if I do that, I get k equals 48. I think my pen's going out here. Let's see. Okay, so that would mean that my function for this relationship is going to be 48 divided by x. All right, so this is inverse variation. That means as my x is increasing, my y is decreasing, or vice versa, okay? So if we want to figure out what this function is going to look like, we are going to type this into our y equals in our calculator, and we're going to plot as many points as we can, okay? One thing about inverse relationships, x cannot be 0, okay? So we're going to look at this in class, what that means, but that's going to mean something specific about the graph. X cannot be 0 because we can't divide a number by 0, okay? Just mathematically, that's against the rules, okay? So what I want you to do, we'll explore this more next week, but I want you to type that into your calculator in y equals, graph it, and then sketch a quick graph right here on your own. Pause the video and do that now, okay? All right, so now that we've done that, what you're going to do is you are going to tell me what y is when x is 10. So that means we are going to plug in 10 for x, and then we're going to get 4.8 when we do that, okay? And just to check your graph, when you type it in, you should have gotten something that looks a little funky, like there's 2 parts going on your graph. But in the first quadrant, you should see something that looks like that. My graph's not accurate. I'm just giving you kind of a sketch of what it should have looked like. And I'll give you a hint. There is an asymptote involved in this type of function. All right, so what I want you to do now, again, I want you to, hold on. Pause the video, and I want you to try this one on your own. Again, come up with that equation, type it in your calculator once you've gotten it, sketch your graph, and then tell me what y is when x is 2, okay? All right, so this one again is varying inversely, so that means my function is going to look like this. So -7 equals k divided by 8. So I can see that k is -56, okay? So my equation is going to be -56 divided by x, okay? So again, make sure you had the right equation. You're going to type that into y equals, don't forget your negative, and then sketch a graph of that, okay? When you see that, like I said earlier, it's going to be like a, actually I think this one is flipped. It is flipped. So you'll have that same graph like we did on the last one where there's like 2 parts of it, but it'll be flipped over, and I should have given you another quadrant right here. Make sure also if when you're typing it in your calculator, you have all your scatter plots and all that kind of stuff turned off, because that can mess with this kind of graph, okay? All right, so let's figure out what y is when x is 2. So y equals -56 divided by 2, okay? So if I cut 56 in half, that's going to be -28. So at 2, y is -28, okay? All right, now let's look at a real-world application of this. So it says your math class decided to pick up litter each weekend in a local park. Each week, there is approximately the same amount of litter. The table shows the number of students who worked each of the first 4 weeks of the project and the time needed for pickup. Okay, so as I look at this table, I can see as my number of students is increasing, the time that it takes to complete the job is decreasing. This makes me think of that phrase, many hands make for light work, okay? So in my head, I'm thinking, all right, if x increases and y decreases, that is an inverse relationship, okay? And I can see that from the numbers, all right? So x is increasing, y is decreasing. This is inverse. So my equation is going to look like this, k divided by x. So let's pick a pair of numbers and figure out what k is, okay? So let's use this. So this is my x value, this is my y. Things aren't always labeled as x and y. You have to ask yourself which one is independent, which one is dependent. Okay, the time it takes to complete the job depends on the number of students. Therefore, x is the input, y is the output. Okay, so I've got 85 minutes is my output for 3 students. I do not know k. All right, but I can check on my calculator. What is 85 times 3? That is 255. So this means that my function that models this data is 255 divided by x, but I'm not using x and y, I'm using n and t. So let's be accurate. We're going to say the time equals 255 divided by n, the number of students. Okay? And then this last question says determine the number of students needed to complete the project in at most 30 minutes. So we're trying to figure out n for 30 minutes. So let's use our function. So we've got t equals 255 divided by n. We don't know this, but we do know that t is 30. So we're going to set this up and plug in 30. Okay? I know I've mentioned this in class before. When you have a situation where you're solving for the denominator of a fraction, you can use this little trick where we flip these two numbers, okay? So the 30 and the n can change places. And the reason why, remember, multiplication is commutative, meaning I can flip-flop things and get the same product. And really what this is saying is 30 times n equals 255. So the order of n and 30 do not matter, okay? So side note, this means that n is 255 divided by 30, which if I type that in my calculator, I get 8.5. But remember, we don't measure people in halves, at least we don't in 2026, okay? So that means that the number of students required to complete the job in under 30 minutes would be 8. Okay? All right. So the last part of section 8.1 is about combined and joint variation. So combined variation is when one quantity varies with respect to 2 or more quantities. So it varies with respect to 2 or more quantities. So if you're like, what does that mean? It just means we're adding another variable. So instead of just y and x, we're going to have like a z thrown in there, okay? And then a joint variation is when one quantity varies directly with 2 or more quantities. So key word here is directly, okay? Combined may not be a direct variation, joint is a direct variation, okay? So let's see what an example of that would look like. So it describes the combined variation here, and we're going to write down an example of what that equation would look like, okay? So z varies jointly with x and y. So what this would look like, it would be in the same form like we've been saying y equals kx, okay? So this would be z, I've added a third variable, kx, y. So it's the same thing, but I'm adding that third quantity into the equation, z. Okay, and then remember if it says jointly, that means direct. Okay, so maybe make a note of that. That's why I use the direct variation format. All right, and then the next one says z varies jointly with x and y and inversely with w. So this is going to be very similar to this equation, but we're adding in that inverse part. Okay, so Z varies jointly, meaning KXY, okay, with X and Y, and then inversely with W. Okay, so that inverse is going to mean division. And then the last one, Z varies directly with X and inversely with the product WY. So we're going to have KX on top and then the inverse part WY down here. Okay, so combined and joint variations are when we add a third, fourth, fifth variable. We'll probably only do the third variable for the purposes of this class. Okay, so let's look at an example of what this would look like with a real world problem. Okay, so it says the number of bags of grass N needed to reseed a yard varies directly with the area A to be seeded and inversely with the weight of the bag of seed. If it takes 2 3-pound bags to seed an area of 3,600 square feet, how many 3-pound bags will seed 9,000 square feet? Okay, so there's a lot going on there. So let's go back and write down, let's highlight some keywords here. Okay, so we know N represents number of bags of grass, okay? So that varies directly with the area to be seeded, okay? And then this is the combination part. So directly with the area to be seeded and inversely with the weight of the bag of seed, okay? We really probably should have put a variable in there for weight. Yeah, that should have been W. So this is W for the weight. Put that right here. So we've got 3 variables going on. So we've got N for the bags of grass. We have area A, and we have the weight W. So let's come up with that combined variation from that first sentence. Okay, so our first variable, grass, okay, the bags of grass needed to reseed a yard varies directly, so that equals K times the area needed to be seeded, and inversely with the weight of the bag of seed. Okay, so basically when you see direct, that's K times the other variable. Inversely is the whatever it's being divided by. In this case, it's the weight. Okay, so it says if it takes 2-pound bags, okay, 2 3-pound bags to seed, and so N is 3 here, to seed an area, A is 3,600 square feet, and then my weight is 3. Okay, sorry, got distracted. Okay, so number of bags is 3, the area is 3,600, and the weight is 3. We are going to plug those numbers into this and figure out how many 3-pound bags it would take to seed now 9,000 square feet. Okay, so if we plug that in and we did the math, we solve for K. All right, so we're going to do 3 equals K times 3,600 divided by 3. Okay, so 3 times 3 is going to be 9 equals K times 3,600. That means that our new value for K is going to be 1 over Oh, you know what, guys? Hold on. Let me back up here. This right here, I wrote down the wrong number for N. This should have been 2. I'm looking at my notes and wondering, what in the world? How'd I get 9? So this should be 2 right here. I wrote down the weight, not the number of bags. It gets confusing. Okay, so this should have been 6 right here. So it should be 1 over, okay, yeah. So if we divide 6 by 3,600, we get 1 over 600. Okay, so what this would mean is now we're applying it to a new situation. So how many 3-pound bags will seed 9,000 square feet? We're now going to use that same equation we came up with, and we're going to plug in this value for K. All right, so let's do that right here. So we're trying to figure out how many bags that's in, okay? And then K is going to be, this is going to look a little weird, 1 over 600 times A, the area is 9,000, and then divided by the weight of the bag is 3, okay? So when we solve that nasty equation, you could type that in your calculator, we get N is 5 bags, okay? Sorry about the typo on that one. Make sure you distinguish, like in these cases where you have like 2 3-pound bags, make sure you put the correct number here, okay? All right, so what I want you to do, I want you to try this question. Go ahead and pause the video, try that one on your own, and then you can check this question. The solution for this is going to be on page 501 in your textbook, okay? And if you don't get the right answer, in class we might do this for the warm-up, okay? But yeah, the solution for that is on page 501. So let me go back. Make sure you have reviewed what the assignment is for this week. Finish chapter 7. Watch this video a couple of times. Make sure you take notes, and then